Okay, so hopefully we're picking up right where we left off. And I was just about to challenge you to multiply this LCD by the numerator of the fraction and by the denominator of the fraction and see if you can simplify that all out. If you haven't tried it yet, give it a try. It's going to be a little messy, but you might be able to fight your way through it, keeping things in factored form and reducing before doing anything else. If you want to try, put me on pause now and try it. If not, stay tuned and I'm going to go through my explanation. So here we go. So on the numerator here, I have a cubed plus b cubed over a squared minus b squared, and I'm going to multiply that by a plus b times a minus b quantity squared. And so right now I'm just concentrating on this part of it being multiplied by my least common denominator. Now when I do that, this a squared minus b squared times this fraction here, well, we know this is a plus b, a minus b. So it's going to reduce with the a plus b and one of the a minus b's, and that's going to go away. So my new numerator is going to be a cubed plus b cubed times a minus b. So that's going to be my new numerator. Now if I go to my denominator, and let me go to a different space, I'm going to have a squared minus ab plus b squared over a squared minus 2ab plus b squared, and I'm going to multiply that by my least common denominator, which was a plus b and a minus b quantity squared. Alright, so what's going to reduce here? Well, this a squared minus 2ab plus b squared is a minus b times a minus b. So the a minus b quantity squared is going to reduce out with that. And now I'm left for my denominator of my main fraction. This is now going to equal a squared minus ab plus b squared times a plus b. Alright, so let's make sure we're organized now. So this is now becoming that. So now I'm going to take my new numerator, a cubed plus b cubed times a minus b, put it over my new denominator, which is right here, and that is a squared minus ab plus b squared times the quantity a plus b. And now notice I have no more complex rational expression. It's not complex anymore. It's just fractions over, it's just one fraction. Polynomials over polynomials. Now notice these are factored. So I have two factors on the top, two factors on the bottom, and nothing seems to reduce. But notice this factor on the bottom. There's no 2 in front of the AB. So this can't be factored out any further. It's prime. But this is a factor of a perfect cubes. And when I look up here on the top, I see I have the sum of 2 cubes. So I'm wondering, if I factor the sum of 2 cubes, is it going to reduce with something below? And it does. So a cubed plus b cubed is a plus b, a squared minus ab plus b squared, and then I still have that a minus b from before, over a squared minus ab plus b squared over a plus b. Now look, a plus b, a squared minus ab plus b squared, a squared minus ab plus b squared. My final answer out of all of that, that all simplifies down to a minus b. Alright, I hope that was helpful. We'll get a chance to practice that in class tomorrow as well. And here's the final variety. Here's the final variety of questions you'll see. And you know, we kind of talked about it at the beginning of the first video. X to the negative 1, x to the negative 1. That can simply be rewritten as 1 plus 2 over x and 3 plus 1 over x. And now this turns into a problem just like we started with. Try this one on your own. Identify the least common denominator and then simplify this complex rational expression. Give it a try. Okay, so now x plus 2 distribute the x, that's x, distribute the x's cancel, and you get 2. Here, distribute the x, you get 3x. Distribute it here, the x's cancel, you're left with 1, x plus 2 over 3x plus 1. Final answer, done. And lastly, this is the last example problem. Ooh, this is a hot mess. Okay, so first identify where's the main fraction bar. Where's the main fraction bar? There it is. Now in my numerator, I have y times x minus y as the denominator, as the least common denominator of my numerators, and then down here I have x times x plus y as my least common denominator of my denominators. So what I need to do is I need to find the least common denominator of my denominators, and because nothing is in common, it looks like it's going to be x, y, x plus y. Yeah. Don't know why it's doing that. X, y, x plus y, x minus y. That is going to be my least common denominator this time. So let's see what happens if I multiply my least common denominator by the numerator and then again by the denominator. So this is going to be multiplied by x, y, x plus y, x minus y, and then the bottom is going to be multiplied by x, y, x plus y, x minus y. I think when I go too fast, that's what makes it happen. Alright, and so that's going to be multiplied by the bottom. Okay, so this is going to be a little hefty, so I'm going to take this and I'm going to multiply it to this fraction right there. Now the x minus y's are going to cancel when I do that, but nothing else is. So x times y times x plus y times y is going to get me x y squared times x plus y. And now this plus sign is going to come down right there. Now I do the same thing, but now I multiply it to this fraction, and the only thing that's going to reduce here are the y's. So with the y's reducing, then I'm still left with x, x plus y, so I have the x plus y here, I have the x plus y here, so that means I have to square it, and I still have the x minus y. And now on the bottom, I can do the same thing. I'm going to multiply this into here. The only thing that's going to reduce is the x. So I'm going to be left with y times, let's see, the x reduced, y times, I'll go with the x plus y from right there, and then x minus y and x minus y. That's going to be x minus y squared. Bring the plus sign down, and then here when I distribute it to this part of the fraction, the x plus y's are going to cancel out, but I'll still have x y squared and then times x minus y. Alright, let's take a look at this. This looks pretty awful. This looks pretty awful. We wouldn't be done. This wouldn't be considered factored form or anything. We want to distribute through the parentheses, multiply this all out, and then re-evaluate. So I'm wondering if on this problem it wouldn't have been better to check the alternate method. This looks pretty messy. Let's take a look and see how that alternate method looks. The alternate method. So let me do this. Let me clone my page. Clone page. Boom, now I got the new page. Let me clear the ink off of here. Clear page. Oh, not clear completely. Undo. Clear ink. Clear ink. There it is. Okay, so now let me try this again. Let me use the main fraction bar. Now let me just simplify the numerator. Let me get a common denominator here. This one I'm going to need to multiply by y over y. This one I need to do x minus y over x minus y. Now over here this becomes y squared. This becomes x squared minus y squared over my common denominator of y times x minus y. My main fraction bar. Now down here my common denominator is going to be x times x plus y. This needs an x plus y. That is annoying. And this needs, oh wait, still here. And this needs an x over an x. So now on the top, x plus y times x minus y, that's going to get me x squared minus y squared. And then plus y times x, I can write as xy. And this is over the denominator, x times x plus y. Now there's a couple things that we want to pay attention to. In my numerator up here, y squared minus y squared is going to cancel out. And down here, nothing seems to cancel out. So now I have x over y times x minus y divided by, that's my main fraction bar, divided by x squared minus xy minus y squared over x times x plus y. Instead of dividing by a fraction, let's multiply by the reciprocal. So x over y times x minus y. Sorry. Deep breaths. So x, so that's my numerator right there. It's coming right here. But instead of dividing by this fraction, I'm going to multiply by the reciprocal. So the reciprocal would then put x times x plus y on the top, and x squared minus xy minus y squared on the bottom. Boom. And then just writing it as one fraction would be our final step. Final step, write it as one single fraction. Equals x squared times x plus y over y times x minus y times x squared minus xy minus y squared. Final answer. Not pretty, but this is considered simplified form. Sorry for taking so much of your time. I know you'll benefit from it come class tomorrow. Alright, looking forward to seeing you then. Take care.